What the? Look, do you see this? Part of the sun has broken off, and it's now churning above the star's surface, having formed a giant vortex. What's going on there? Well, let's admit it, we still know very little about the sun, however crucial this star is for our well-being. But in the case of the broken sun, scientists can probably explain what happened. Some of the star's plasma likely erupted from the sun's surface and broke away, creating something resembling a crown-like vortex over the solar North Pole. And still, this is just a theory. Astronomers need to conduct further analysis to figure out if this is what really happened. At the moment, they're a bit baffled since this phenomenon is nothing like anything they've seen before, but the footage we've got is undeniably impressive. What is more alarming, though, is that the behavior of our star is currently changing. The sun is ramping up its activity. It's getting rowdier with flares and sunspots. This year, it has flared every day so far. It has also thrown up a few X-class and M-class flares in January 2023. These flares are the largest and second largest eruptions our star can produce. Even though it sounds kinda alarming, don't worry, the sun has certain activity cycles that repeat every 11 years or so. Some of them are relatively calm, while others are absolutely wild. These cycles happen simultaneously with the fluctuations in the sun's magnetic field. When it gets the weakest at the star's poles, they switch places. This makes the polarity of the magnetic field reverse. This is the very period of time when the sun is the most active. It's known as solar maximum. Right now, we're near this solar maximum. Scientists can figure it out by analyzing unusual solar activity. But since the sun is still pretty much a mystery to us, no one can determine when the polarity reversal is likely to occur. A rough estimation is July 2025. At the same time, we can't say that the current solar situation is normal. It's true that each sun cycle is different from others. Some are weaker, and some are more powerful. So this one, which started in December 2019, has already significantly exceeded all scientists' expectations and keeps doing so. Which brings us back to the vortex observed on February 2nd, 2023 that impressed astronomers so much. It started as a solar prominence. This is a bright plasma filament extending away from the surface of the sun. And let me tell you, solar prominences are an absolutely regular phenomenon. And like the most recent one, they often occur at high altitudes around the sun's crown, which is the outermost layer of the star's atmosphere, also known as the corona. Anyway, prominences like the one in question are called hedgerow prominences because they look like a hedge. But what surprised astronomers happened a bit later. The material of the filament apparently broke away and started circling the pole near which it occurred at 60 degrees latitude and at a speed of about 100 kilometers per second, and it lasted for about 8 hours. One scientist who has been observing the sun cycles for decades claims that he has never seen vortices like that. Unfortunately, solar poles are very difficult to observe, so it might be a while till we get our answers. For the first time, a spacecraft touched the surface of the sun in 2021. It was NASA's Parker Solar Probe that flew through our star's upper atmosphere. It also took some samples of particles and examined magnetic fields there. It was a real milestone and a giant leap for solar science. Getting their hands on the very stuff the sun is made of will allow researchers to uncover crucial information about our star and its influence on us and the entire solar system. The Parker Solar Probe moved closer to the sun's surface and started making discoveries that other spacecraft were too far away to see. For example, the probe examined the solar wind from within. It's a flow of particles coming from the sun. These particles can influence us here, on Earth. Even before coming super close to the star, the Parker probe found out that near the sun, there were loads of magnetic zigzag structures in the solar wind called switchbacks. But at that time, scientists couldn't figure out how they formed and where they appeared. But now, more than 2 years later, we know for sure that switchbacks originate at the solar surface. As you know, the sun doesn't have any solid surface, unlike our planet. But it has a superheated atmosphere, which is made of solar material bound by magnetic forces and gravity. When pressure and rising heat push that material away from the star, it eventually reaches a point where the sun's magnetic field and its gravity can't contain it anymore. This point has its own name, the Alfvén critical surface. It marks the edge of the solar atmosphere, and that's also where the solar wind begins. The material that manages to make it past the boundary turns into the solar wind. It drags the sun's magnetic field toward Earth and beyond. But the most important thing is that past the boundary, this wind starts moving so fast that its waves can't return back to the sun, which literally means severing all connections with the star. During its flyby, the Parker probe passed inside and out of the sun's corona several times, which proved that the Alfvén critical surface wasn't shaped like a smooth sphere. It has valleys and spikes, and its surface is kinda wrinkled. At one point, the probe even came across a pseudo-streamer. These are massive structures in the sun's corona that rise high above the surface of the star. You can see them from Earth during solar eclipses. And you know what? For the Parker probe, passing through that pseudo-streamer was like flying into the eye of a storm. Inside, everything was much quieter. Particles moved more slowly, and there were fewer switchbacks. It was a huge change from the barrage of particles the probe encountered inside the solar wind. Now, speaking of solar flares, those are pretty dangerous for Earth. The radiation they release can interfere with our radio communication. Such storms affect all electronic systems, from the internet to power grids, and can even destroy satellites. Most solar flares last for minutes, but some continue for hours. Scientists classify solar flares depending on how brightly they shine in X-rays. You aren't likely to notice the tiniest flares if you don't have special equipment. Medium solar flares lead to fleeting radio blackouts at the poles, but nothing too serious. It's X-class flares that people should be worried about. They cause the strongest and longest-lasting solar storms. A super strong solar storm heading toward Earth won't happen at once. First, there will be high-energy sunlight, mostly ultraviolet rays and X-rays. They will ionize our planet's upper atmosphere and mess up radio communication. After that, a radiation storm will hit Earth. And finally, a colossal cloud of charged solar particles will reach our atmosphere. The particles will interact with the planet's magnetic field and wreak havoc all over the world. If an intense solar storm happened these days, it would start by disrupting GPS and knocking out satellites. If any astronauts were spacewalking at that moment, they would have mere minutes after the first flash of light to find shelter. Their spacecraft would likely be properly shielded and safe enough. The main challenge would be to get inside in time. After that, the storm will proceed to interfere with satellite communications. That's why tons of your daily activities, from calling your friends to paying with your credit card, would be at risk. But one of the worst consequences would be connected with power grids. Power surges caused by the particles coming from the sun would damage giant transformers. A powerful solar storm could cost people $1 trillion to $2 trillion. Luckily, if such a powerful solar storm was heading our way, we'd most likely get some kind of warning. Modern equipment all over the world and in space doesn't stop watching the sun even for a second. It would give us some time to prepare, between several hours and a couple of days. And if transformers were taken offline in time, the consequences wouldn't be so dramatic. A recent study has involved almost 200 huge stars that are reaching the end of their lives. It has given scientists more precise information about how the sun will one day end. It turns out that the sun will be about 200-300 times bigger than it is now by the time its game is over. For starters, let's begin with some basic information about star sizes. Giant ones reach this stage because they've run out of nuclear fuel and are no longer burning hydrogen in their core. Eventually, the core gets hot enough to trigger the next stage of fusion, which is helium burning. All the stars that were surveyed in this new study were either in this hydrogen shell burning or helium core burning phase. Even though giant and supergiant stars only make up less than 5% of all stars, or at least that we know of, they're actually really visible from a distance because they're so bright. In fact, according to scientists, about a third of all the stars you can see outside on a dark moonless night are giant or supergiant stars. This study will eventually give astronomers really useful info about massive stars. They'll be able to figure out their size and temperature, no matter where they are or their evolutionary stage. This means they can see a star's true color and use that to find out its radius. Pretty cool, right? It does raise the question, what will our sun be like when it gets old and grumpy? To put it simply, it will expand when it starts burning its hydrogen shell, but then shrink a bit during its helium core burning phase. After a few 100 million years, it'll end up as a giant star about 200 to 300 times its current size. Eventually, the sun will expand so much that it will simply evaporate. So, what will happen after the sun fades away? Scientists actually have some predictions about what will go down, even though we won't be around to see it. They're pretty sure the sun will turn into a planetary nebula. These planetary nebulae are chunks of gas and dust in space that come from a star that is fading away. They got their name because they looked like planets to people using telescopes back in the 18th century, even though we now know they have nothing to do with actual planets. But here's the crazy thing. Astronomers have found out they can use the level of brightness of these planetary nebulae to calculate their distance from us. In 2018, scientists also found out that the sun is the smallest a star can be to still be able to produce a visible nebula. Any smaller, and it would not be visible. Stars that are up to 3 times more massive than the sun will produce brighter nebulae. The sun is currently 4.6 billion years old, but it's estimated to have another 10 billion years until its end. The sun is also getting brighter with each year. It doesn't seem like a lot now, but it's actually going to cause some big problems for Earth. In about 1 billion years, the sun will be too bright for life on Earth to survive. Our oceans will evaporate, and it will be too hot for water to form again. So, unless we find a way to escape from this planet, humanity only has about 1 billion years left. Will Earth still be around by the time the sun turns to dust? It's hard to know for sure the exact timeline, but even before that happens, Earth will most likely be scorched and lifeless, with no atmosphere or oceans left. It's not clear how close the sun's outer layers will get to Earth, but if they get too close, it could cause Earth to spiral into the sun and disappear altogether. Even if our planet does somehow manage to survive the sun's giant phase, it will be orbiting a hot white dwarf, or a star that has run out of its fuel. In that distant future, the sun will be barely larger than our planet. Eventually, the sun will cool and dim completely. It'll move to another stage called a black dwarf. It will cause Earth's orbit to loosen up, and our planet will spiral into the faded sun. But interestingly, the sun doesn't get the final say in what happens to Earth. Gravity keeps planets in orbit, but it also attracts them to each other, which can cause their orbits to flex and drift. This could lead to the solar system destabilizing and ejecting planets, including Earth. Basically, a lot might happen in the next 5 billion years before the sun becomes a red giant. There's also another scenario. While most stars stay far away from our solar system, there's a chance that one could come closer in the next billion years. Even a small star or black hole could mess up the orbit of our planet if it gets too close. But don't worry too much. The odds of that happening are low because of the amount of space between stars. Our sun is a solitary star, so there's little to no chance we'll be able to catch a ride with another one nearby. However, many stars in our universe have companions. Among these stars is Castor, a stunning system that comprises 6 stars and is one of the brightest objects in the night sky. Although humans have been admiring Castor for ages, they were not aware of its true nature until the invention of telescopes and spectroscopes. Even with the help of a small telescope, it's evident that Castor is composed of 2 primary stars, Castor Aya and Ba, that revolve around each other. These stars are larger than the Sun and need 467 years to complete one orbit. In total, Castor is composed of 6 different stars. The biggest one, called Castor Aya, is roughly 2 times larger than the Sun, while the smallest has about 0.5 of the Sun's mass. If humans want to survive the next billions of years, we might need to set up camp somewhere else in the universe. It may seem like something out of a sci-fi movie, but it could be our reality one day. Thankfully, NASA is already looking at some options. They've discovered 2 new planets, TOI 700e and TOI 700d, that might be new hotspots for us humans. TOI 700e is in the optimistic zone, which means it could have water and even an atmosphere. TOI 700d is in the conservative habitable zone, so scientists aren't too sure about it yet. But hey, we'll take what we can get. But hold on. Before you start packing your bags, there's a little problem. How do we get there? It took John Glenn months of preparation just to circle Earth 3 times, so we might need to start working on our astronaut training. Well, at least we have some options for our future intergalactic vacation plans. Wouldn't it be nice if we could time travel so we could see what our solar system will look like in billions of years? An American physicist named Ron Mallett has proposed one interesting theory for time travel. It uses light, a resource that is abundant in the universe. His idea involves using a rotating cylinder of light, which could transport an object in both space and time, similar to how a bubble moves in a swirling liquid. Mallett suggests that a cylinder of the right shape could allow for travel to the past and the future. To test his theory, he has been trying to secure funding for an experiment. However, some scientists consider Mallett's theory to be impossible and unnecessary to test. We might also be able to travel through time if we move fast enough. According to Einstein, the way we experience time can change depending on how fast we're moving. If we go really fast, time slows down. For example, astronauts in space age a tiny bit more slowly than people on Earth. This is important for things like GPS, which would be incorrect without special adjustments because of how time is affected. Let's face it, as stars go, our sun is actually, well, pretty boring. Come on, there's nothing unusual about it. There are millions of similar yellow dwarfs in the universe, and yet we love it. After all, it's the only star we have, and it gives us life. However, it wasn't always like that. Once upon a time, the sun had a twin, possibly an evil one. What happened to it? Well, let's find out. This here is a giant molecular cloud. They're also sometimes called dark nebulae. Here, there are many interstellar clumps full of gas, dust, and piles of stars. These clouds have no clear boundaries and often take weird, crazy forms. You can even see some of them with the naked eye. Look at the clear sky at night. They look like dark spots all across the bright Milky Way. And this is exactly where our sun was born about 4.5 billion years ago. The sun originated from one of these molecular clouds. Billions of years ago, waves of energy were passing by here. They collected all this material and compressed these clumps into dense nuclei. That's when a protostar was born. This young protostar was a ball of lukewarm hydrogen and helium. And then, millions of years later, the temperature and pressure inside the balls increased. As a result, a star was born, the sun. But not everything in this molecular cloud has turned into the sun. The remaining materials began to revolve around the new star, and as you might have guessed, they gradually turned into planets, including our Earth. This is how our solar system was created, but it's quite possible that this is not the whole story, and that at the same time, along with our star, another one was born, the lost twin of the sun, made from the same materials under the same conditions. But why do we think that it exists? Recently, scientists have launched some statistical models to find out more about the birth of stars, and these models have shown that many stars appear not individually but in clusters, or with at least one sibling. After more research, scientists confirmed that, yep, most stars formed inside molecular clouds are born with a companion. Sometimes these companions stay together. For example, a small star will revolve around a large one. They can even form double, triple, and other star systems. And sometimes, their paths may diverge forever. This probably happened to our sun as well. It could have had a sibling, perhaps not even one, but a whole cluster of little brothers and sisters, in one bigger twin with a similar mass and other characteristics. But if that's the case, then where are you, our lost twin? Well, we have one hypothesis, and according to it, this twin may not be as good as it seems. In the 1980s, scientists began to notice a certain pattern in the Earth's history. Approximately every 27 million years, give or take, large-scale extinctions occurred on our planet. Pretty strange, right? Every 27 million years in the history of Earth, some kind of catastrophe occurred that changed its biosphere forever, as if something, as scheduled, cyclically, caused them. Then an astronomer, Richard Muller, suggested that there may be something that caused these events, a certain celestial body. According to him, it could be a dwarf star that we can't see because of how dim it is. It could be located about 1.5 light years away from us. This star rotates around the sun in a huge orbit, and it approximately takes a whopping 27 million years for it to finish its orbit. And when it gets the closest to the sun, it starts to cause complete chaos. While approaching us, this troublemaker changes the trajectories of comets in the Oort cloud, or the Kuiper belt. As a result, all these comets start to rush straight toward us. Then they crash into the Earth and cause mass extinctions, just like it was with dinosaurs. This hypothetical star was named Nemesis. It's the name of the ancient Greek deity of retribution. What is it taking revenge on us for? No idea. Perhaps it didn't like the fact that once upon a time, the sun took away almost all the dust and gas from a molecular cloud. The sun became a fairly large star, but the twin remained dark and small. Moreover, in the end, it was forced to fly away in the middle of nowhere. Anyone would be annoyed by something like this. Scientists have put forward various hypotheses about what the mysterious Nemesis is. Perhaps it's a brown or red dwarf, the remnants of a star that has completely depleted its fuel. Or maybe it's not a star at all, but a rogue planet more gigantic than Jupiter. Whatever it is, its existence isn't particularly pleasant for us. However, all our attempts to find the culprit, unfortunately, failed. At the moment, we still haven't found any signs of Nemesis. Recent studies have called into question the theory of regular mass extinctions. If you look more into fossil records, you'll notice that these catastrophes occurred rather randomly, rather than on a clear schedule. Now scientists doubt if Nemesis may actually exist. They also say that any star moving in a similar orbit would be very unstable, and it's very unlikely that it could have survived for that long. But despite the lack of clear evidence, Nemesis has become quite famous online. Many articles and news still mention it in different contexts. They like to write off any dramatic events taking place in the world, like asteroid falls, tsunamis, and so on this mysterious star. So now all this may seem like a typical urban legend. But let's not forget about something important. Even if Nemesis itself doesn't exist, it doesn't mean that the sun didn't have a twin. First of all, everything we talked about at the beginning is still relevant. Most stars aren't born alone. The probability that our sun also had a sibling is still very high. Secondly, there may be evidence of the existence of this lost twin, and it's probably somewhere in the Oort cloud. This is a huge cloud in the outer limits of our solar system. It consists of a bunch of comets and other cool rocks. Now, scientists believe that this cloud stores various remnants and fragments of everything that remained after the birth of our solar system. It's like a huge museum of our past. So, in this Oort cloud, scientists have noticed something interesting. Basically, this region seems to be too heavy. What the Oort cloud actually looks like doesn't correspond to our current models of the formation of the solar system. It's too heavy because there are some remnants of something in it. So there used to be something in the solar system that we don't know about yet. But when scientists included a possible second sun in their calculations, it fit just right. Like a missing piece of a puzzle, the lost twin perfectly matches the gap in the weight of the Oort cloud. So yeah, the sun almost certainly had a twin. But what happened to it? And where is it now? Unfortunately, this star is most likely already very far away. Probably after their birth, the sun and daughter, Sun 2.0, spent only a couple of million years together, and then they had to separate completely. Now this second twin may be hundreds of light years away from us. It can be anywhere in the Milky Way. And yeah, theoretically, we could find it, but that would be quite difficult. To do this, we need to find all the stars similar to our sun, about the same age, all over the Milky Way. And even if we make a list of these stars, what's next? We have no way of knowing which one was really the twin of the sun. So the lost twin will most likely remain lost, and our sun will remain forever lonely. What a sad story. But cheer up. For us, it's probably for the best. If we had two suns, perhaps the solar system would never have become what it is now. Our planet might not exist at all, and that means that there might be no life. So we probably should be grateful for sun sacrifice. On the other hand, our sunsets would look like the ones they have on Tatooine. Cool.
What happens when a star runs out of its fuel? First of all, paradoxically, it grows to 1,000,000 times its original size. You see, when the core of a star runs out of hydrogen, it starts contracting under the weight of its own gravity. But some hydrogen fusion continues in the upper layers. While the core contracts, it heats up. This causes the upper layers of the star to heat up too and expand. The radius of the star increases. As the star grows, it engulfs any matter, even its own planets, in its wake. Astronomers have watched stars right before or straight after swallowing entire planets, but until recently, they have never seen the process itself. Scientists from different universities have reported that for the first time in history, they've observed a star swallowing a planet. And this tragic event happened not somewhere in a faraway galaxy, but in our own Milky Way, some 12,000 light years away from us. Astronomers spotted an outburst from a star, which is around 0.8 to 1.5 times the mass of our sun, near the eagle-like constellation, Aquila. It became over 100 times brighter than usual in a mere 10 days, and after that, it quickly faded away. Even more interesting, this white-hot flash was followed by a longer-lasting signal that was also colder than the first flash. And this combination, my friend, could only mean one thing. The star engulfed a nearby planet. What planet was it? Astronomers believe it could be a boiling hot world from 1 to 10 times the mass of Jupiter. Such planets are also called hot Jupiters. They're giant exoplanets similar to the Jupiter we have in our solar system that need less than 10 days to orbit their stars. The planet we're talking about had been gradually spiraling toward the star until it was pulled into its atmosphere and, eventually, into the core of the perishing star. This galactic feast happened between 10,000 and 15,000 years ago when the star was about 10 billion years old. And given its respectable age, the swallow itself happened lightning fast, in one fell swoop. This is very different from other hot Jupiters, which were quite delicately nibbled by their stars. Astronomers aren't sure if there are any other planets orbiting this star, perhaps at a safer distance. But even if there are, thousands of years will probably pass before they become the star's main course or dessert. In any case, now that astronomers know what they should search for, they're going to be on the lookout for more cosmic gulps. Because one day, our planet, as well as part of our solar system, will suffer the same fate. Everything around us will be gone in a flash. But you may relax and breathe out. It won't happen for another 5 billion years. That's when the sun is supposed to burn out and expand so much that it will swallow the inner planets of the solar system: Mercury, Venus, Earth, and Mars. If people manage to colonize some other world by that time, which should be at least 10,000 light years away from Earth, they would be able to observe this catastrophe. The sun would suddenly become much, much brighter, and it would eject some material into space. It would swallow several planets, including Earth, before nonchalantly setting back to what it was. But stars are not the only things in the universe that swallow other space objects. There's another kind of cosmic monsters that munch on everything, even light. Have you guessed? Right. I'm talking about ruthless black holes. But what is more interesting, they not only devour stuff but also seem to spit it out. Not so long ago, scientists found out that the supermassive black hole at the center of our home Milky Way galaxy seems to be leaking. Why is it a game changer? Because it might mean that this black hole, called Sagittarius A*, whose mass is 4.1 million times the mass of our Sun, isn't a sleeping giant as previously thought. It might still be active, and this leakage may be the whole hiccuping while swallowing clouds of gas. During the research, the team of astronomers used the Hubble Space Telescope. It helped them spot a jet that looked like a blowtorch. It was pushing into clouds of hydrogen at the center of our galaxy. The jet seemed to spew gas like a hose directed into a pile of sand. This often happens around active black holes, surrounded by the material, pulled toward them by their immense gravitational pull. Some of this material gets into the black hole, but a small part of it gets swept outward by powerful magnetic fields. The research suggests that when a giant gas cloud gets too close to our supermassive black hole, it gets swallowed, and then the hole belches mini jets of matter. Fermi bubbles might be the result of the belches that happened around 2 to 4 million years ago, but recently, scientists have discovered another giant glowing bubble of hot gas. It aligned with the jet stretching for 35 light years or more from the supermassive black hole. Astronomers suspect that the jet could have plowed into this bubble of gas and inflated it. Now I'll tell you something even creepier. There seem to be black holes that might be eating each other. Well, kind of. They're actually trying to share their meal at the moment, but who knows what will happen in the near future. But let me go into detail. Astronomers have spotted 2 supermassive black holes, feasting on the cosmic material of 2 merging galaxies in distant space. These giants have been located with the help of the Atacama Large Millimeter Submillimeter Array of Telescopes, also known as ALMA. These telescopes are in northern Chile's Atacama Desert. Scientists originally used them to watch 2 merging galaxies located about 500 million light-years away from Earth. Astronomers have also noticed that 2 gigantic black holes were growing alongside each other not far from the center of the coalescing galaxy, UGC 4211. Apparently, these black holes came across each other when their host galaxies collided. One of the black holes is around 200 million times the mass of our Sun, and the other is a bit smaller, about 125 million times the mass of our star. Even though they aren't visible directly, the black holes are surrounded by bright clusters of warm, glowing gas and stars. All of this has been tugged close by the black hole's gravitational pull. Times will pass, and these black holes will start circling each other. And eventually they will collide, creating one, probably even bigger black hole. Scientists have been observing these black holes across multiple wavelengths of light and have come to the conclusion that they are kinda unique. They're located the closest to each other astronomers have ever seen. The distance between them is a mere 750 light-years, which astronomically speaking, is just next door. Even more exciting, this distance is close to the limit of what modern technologies can detect. Interestingly, such ginormous merges are more typical for distant galaxies. This makes it harder for Earth-based telescopes to see them. But the sensitivity of ALMA helped astronomers observe those bright and compact regions where matter swirls around black holes. Imagine how surprised astronomers were when instead of one black hole, they saw two of them, munching on the dust and gas stirred up by the massive space merger. The most important thing about this discovery is that it may mean that such black hole binaries are likely to be much more common than we previously thought. And if pairs of black holes are so common, it might make it easier for us to study gravitational waves that occur when black holes collide. Such waves are also known as ripples in spacetime. If we talk about the recently discovered pair of black holes, it might still take them several 100 million years to crash into each other. But by observing their behavior, scientists can figure out how many binary black holes that are about to collide exist in the universe.
Consider the rogue planet, the cosmic wanderer that nobody wants to take home. Basically, a rogue planet is a planet that has been ejected from its own star system and is now floating aimlessly through space like a cosmic loner. These planets aren't just a theory. Scientists have actually detected some in our galaxy. In fact, estimates suggest that there may be lots of these cosmic nomads floating around the Milky Way. And they aren't just small, rocky worlds like Earth. Some of them are actually massive gas giants, many times larger than Jupiter. These behemoths could potentially have their own moons, and even their own mini-systems orbiting around them. For example, one of the most famous rogue planets we know of has a complicated name. Here, you read it for yourself. It's located about 80 light-years away from Earth, and it was discovered in 2013. This rogue planet is estimated to be around 6 times the mass of Jupiter and is believed to be around 12 million years old. And yes, just because these cosmic loners don't have a star doesn't mean that they're super cold. They can still generate heat and light from their own internal processes. Some may even have magnetic fields and auroras, just like Earth. In other words, rogue planets could potentially be habitable if they have the right conditions. So, what would life on such a planet look like? And could we potentially live in such a world? Well, living on a rogue planet can be a lonely existence. They have no warm sun to bask in, no cozy atmosphere to cuddle up in, and no cosmic neighbors to have barbecue with. That's why we'd have to get creative. Let's start with the most obvious problem. We'll have a hard time without light and heat. So how do we fix this? Well, we'd probably have to invest in some really fancy space heaters and wear fashionable super warm spacesuits. Or we could invent a whole new way to generate electricity without relying on solar power. For example, how about using geothermal energy? Now that's hot stuff. Each planet has an internal source of heat. Without it, they all would be nothing more than cold, lifeless rocks floating through space. This internal heat can be harnessed and used to power everything from homes to factories to spaceships. It's like having a hot tub big enough to power an entire city. And that city, most likely, will be located underground, closer to the heat source. And as for light, well, we'd probably have to build some really bright flashlights. Or maybe even learn to genetically engineer some bioluminescent organisms to light up our homes. Just imagine space bases overgrown with neon mushrooms and plants. By the way, speaking of plants, plant life would be pretty hard to come by without a star. So what would we eat? Well, we could use the same geothermal vents that we've talked about, or some chemical reactions to sustain ourselves. And hey, maybe we'd develop a taste for sulfur-rich foods. Or we'd start fermenting our own drinks from the bubbling volcanic mud. Yum. But besides food, we have a more important problem. Living on a rogue planet would be breathtaking, literally. We'd have no air. You see, not all rogue planets have good stable atmospheres. It all depends on their size, composition, and other things. But even if our new home does have an atmosphere, it may be incredibly thin and unstable. We'd have no pretty blue skies or dramatic sunsets to admire. Instead, we'd be staring out into the infinite void of space, where the stars would be brighter than ever before. And forget about weather patterns. Without an atmosphere to create them, we'd have no rain, no snow, and no thunderstorms. And that's just some minor problems. What's worse, the temperature on the planet would be wildly fluctuating, swinging from unbearable heat to unbearable cold. It would be like living in an oven that's always being turned on and off. And finally, we'd be exposed to all kinds of space debris and cosmic radiation. So if you don't want to get crispy, you might want to invest in some serious SPF. So how do we fix it? Well, we'd have to find a way to generate our own oxygen and probably create something like a space-age biosphere. For example, we could grow some plants that could produce oxygen, or we'd learn to filter the air like a high-tech air purifier. Finally, we have the last most important problem: finding water. And here's where the underwater oceans come to our aid. Now we're really diving deep into the possibilities. Haha. But seriously, scientists suggest that some of these planets may indeed have underwater oceans. It would be like living on a giant water balloon that's been buried underground, with the ground beneath your feet made of ice and rock. In other words, we could just tap into these underground oceans. They could provide us with a source of water for drinking, farming, and manufacturing. Maybe even with some other resources and materials we've never seen before. And by the way, who knows what kinds of strange creatures might be lurking in those underground seas? But don't worry. Even if we don't have any underground oases, there are also other options. We could get some water from comets, ice mining, and even from the atmosphere, the one we just created before. Finally, we need to find and mine some resources to build our homes and other stuff. And a rogue planet might not have the same kinds of resources as a planet that orbits a star. It's like trying to find some treasures in a desert. Not exactly a sure thing. We may have to rely on resources from nearby asteroids and things like that. And if we want to extract resources from the planet itself, we might need to drill down through miles of ice and rock. But hey, if you're up for the challenge, there's always a chance you'll strike it rich on a rogue planet. And who knows, maybe you'll discover some new resources that are even more valuable than gold or diamonds. Great! Looks like we've solved the most important problems. There may be other small difficulties. For example, we'd also have to deal with some seriously long days and nights, depending on how fast our planet was rotating, and we wouldn't have a normal, regular day-night cycle. The rotation of our planet could be wildly unpredictable. Maybe we'd have weeks-long nights followed by weeks-long days, which could really mess with our sleep schedules. We might have to develop some really strong coffee to keep us going through those long, dark nights. But hypothetically, we can adapt to all these things and overcome all the challenges. And now, finally, welcome to the Rogue Planet, where the sun never rises, but the adventures never end. Thanks to our advanced technology, we've managed to create a comfortable and habitable environment in this once barren world. The sky above us is now a beautiful shade of blue, filled with fluffy white clouds and the occasional flock of flying creatures. Don't ask. As we venture out from our underground habitats, we're greeted by a world that's full of surprises. Strange plants and animals have adapted to the unique conditions of this planet, some with bioluminescent features that glow in the dark. And be careful if you want to go swimming in the underground ocean. They might be home to some bizarre creatures who want to feast on… well, we'll come back to that. Maybe. As you can see, we've created sprawling cities and thriving communities, powered by the planet's geothermal energy. We also created a bunch of artificial light sources that keep things bright throughout the dark, chilly nights. Of course, we still have some problems with navigation and timekeeping, but things aren't as dull as they used to be, are they? Overall, living on a rogue planet would definitely have its challenges, but it could also be a pretty exciting way to experience the universe. And who knows? Maybe one day we'd find such a planet and actually turn it into a bustling intergalactic metropolis someday. But until then, let's enjoy and tidy up our dear Earth. From where we stand, the sun seems so calm and peaceful. But like humans, and basically the whole living world, the sun has its own phases when it's more or less active. It's just that the consequences are way bigger and more chaotic when the sun becomes hyperactive. Let's zoom in to see what's happening up there. So, one of the ways we measure the activity of our star is by counting sunspots on its surface. Sunspots are dark patches that form when the sun's magnetic field gets all tangled up. It's simple. The more sunspots, the more active our sun is. And it seems the sun has been partying like crazy recently. The number of sunspots scientists have seen is the highest for nearly 21 years. In June, 163 sunspots appeared on the sun's surface. The last time we had so many dark patches across the sun was in September 2002, when there were 187 of them. It seems this chaotic party is getting closer to its peak, and that's something we call solar maximum. How does all this even happen? The sun's magnetic field is strong and organized at some point. But as we said, sometimes comes the time when it kinda ends up tangled, sort of like a ball of rubber bands that are wound together very tightly. This also means plasma is rising from the surface, forming loops, and causing a mess in the shape of solar flares, and something we call coronal mass ejections, CME. That's when plasma in the sun's upper atmosphere called the corona goes crazy and bursts really strong. Then at some point, this ball snaps and completely flips and turns the South Pole into the North Pole and vice versa. All this happens every 11 years or so. So when the sun comes into this phase when it becomes very active, it shoots out hot blobs of plasma, gets big dark spots as large as planets, and releases powerful eruptions of energy and radiation. Something fascinating happens when the sun becomes more active, a thing called plasma waterfall or polar crown prominence, PCP. It's like a mini eruption that starts on the sun, and it seems like it tries to get away, but then the sun's magnetic field pulls it back before it can escape into space. And this plasma waterfall is really spectacular. It goes up to 62,000 miles above the surface. It's like you stack 8 Earths on top of each other. Then, there's something called a polar vortex. It's like a gigantic halo of plasma that rotates around the sun's north pole really fast. This vortex happens when a large tentacle of plasma snaps apart and falls back toward the surface, similar to how a plasma waterfall forms. Scientists don't know why this plasma stays above the sun's surface for so long. And one of the cool examples of CMEs was a giant one in the shape of a butterfly in March this year. It got such an unusual shape because it exploded on the side of the sun we couldn't see, so it was impossible to fully measure how strong it was. Fortunately, that one didn't explode in our direction, but it might have hit Mercury a little bit, and it's possible it knocked off some dust and gas since Mercury has a weak magnetic field. All this sounds cool in theory, but it's not such good news for us. Because of all this, we might experience more intense solar storms that can, again, lead to geomagnetic storms on Earth. And these don't just sound alarming, they indeed are. They create chaos and disrupt the magnetic field of our planet. Geomagnetic storms can create beautiful northern lights, true. But we'd all rather enjoy such beauties as the aurora borealis in regular conditions, or just watch a good old sunset above the ocean. It's not that every solar storm will necessarily hit Earth, even if there are more of them. To reach our planet, they must be pointed in the right direction at the right moment. But if that happens, the storm can ionize the upper atmosphere, and bye-bye our communications. It can cause temporary blackouts for systems such as GPS and radio. It isn't necessarily a big problem on its own, but it can be very dangerous if it happens at the wrong time, like during a tsunami or an earthquake. The storms can also damage electrical infrastructure like rail lines and power grids. If you're on a plane at that time, you might be exposed to higher levels of radiation. It's still not clear how dangerous that will be for you, but it can be a serious problem for astronauts in space. When solar storms mess with the magnetic field, this can affect the migrations of some animals, such as sea turtles, whales, and birds. Since things in the animal kingdom mostly work in the natural order, who knows how these animals go through or even survive such changes? And when the sun is at a maximum of its activity, satellites in space are in trouble too. We have more satellites in space than ever before, and when the upper atmosphere becomes denser because of all these changes, this can push satellites in different directions. They might crash into one another, or some can even fall back to Earth, which again is only cool in movies with superheroes who can relatively easily deal with this stuff. Hopefully, we'll avoid a massive solar storm like the Carrington event. The story was similar. In August 1859, astronomers across the globe watched how the number of sunspots was getting bigger and bigger. A man named Richard Carrington was among them. At the beginning of September, he was sketching the sunspots when, out of a sudden, he was blinded by a flash of light. It lasted around 5 minutes, but it was spectacular. He later described it as a white light flare. It was a very strong coronal mass ejection, CME, and in only 17.6 hours, this storm crossed the long way between the sun and our home planet, 90 million miles, and unleashed its force on us, even though this usually takes days. And when this storm started, telegraph machines across the world sparked. Operators got electric shocks, and paper even caught fire. People were really scared and confused because they had never seen such bright skies before. Some even thought it was the end of the world. The next day, telegraph workers still couldn't work properly because Earth's atmosphere was still charged. They even managed to send messages using the auroral current instead of regular electricity. But it brought something incredible too, stunning auroras in the sky. People in Hawaii and Cuba could see beautiful northern lights, while those as far north as Chile could see the southern lights. It's all slowly but steadily escalating. Take solar flares, for example. These are powerful bursts of energy from the sun. In 2022, there were 5 times more of these flares compared to the previous year, plus the strongest ones. X-class flares have been getting stronger and more common than before too. And this might be way more extreme than anyone thought. Plus, it's likely to start a little bit earlier than we predicted. Scientists first thought the peak would happen in 2025, but it seems it could even occur by the end of 2023. We can't completely protect ourselves if a solar storm hits us directly, but we can still do some things, like ground planes, adjust the paths of satellites in space, and try to make sure vulnerable infrastructure stays safe. To do all this, we need better solar weather forecasts to help us get ready for the worst. All this might sound very bad at first, but don't worry, solar flares won't destroy our planet. They do send charged solar material toward us at pretty high speeds, but it's not like we're completely doomed if these things hit us. Our planet won't leave us unprotected. We still have the atmosphere and magnetic field that keep us relatively safe. Our thick atmosphere is like a shield that blocks radiation that might harm us. So, these solar flares can mostly affect technology, but they won't destroy Earth. I guess we have our own superheroes after all.
So listen up. One day our sun will cool down and turn into a white dwarf. But this is not the worst thing for Earth. Before the star cools down, it will grow to an incredible size and arrange Ragnarok for us. Now, in case you don't know, Ragnarok is the fire apocalypse from Nordic mythology. So our star will burn down absolutely everything on our planet. But hey, don't worry, there's good news. This one day will come in 5 to 7 billion years. The bad news, though, is that almost all complex life on Earth will become extinct much sooner, maybe in 250 million years. But there's a small chance that our planet will be ruled by octopuses. Yeah, I know, this is too much news for the first few seconds. So let me break it all down for you, one thing at a time. We all hear about people destroying nature and polluting our planet. This is all true, but even without our intervention, the vast majority of living creatures on the planet will disappear, including ourselves. The reason is natural disasters and weather change. It sounds terrible, but it's not new to Earth. Scientists have found out that there have already been 5 mass extinctions. The last one happened about 65 million years ago, when dinosaurs disappeared. But life won anyway and took on many different forms. The 6th apocalypse may occur within the next 250 million years. Conditions on Earth at this time will be unsuitable for mammals because the level of carbon dioxide will be twice as high. This will happen because the sun will release 2.5% more radiation and it'll get too hot on Earth. The temperature in most parts of the planet will reach between 104 to 158 degrees Fahrenheit, and the entire land will turn into one supercontinent. In regions with high humidity, the temperature will be even higher, and of course, under such conditions, it will be difficult for people to walk in the park and play frisbee with dogs. No one will play with anyone at all. Let's hope we'll have colonized other planets by this time. Increasing solar fluxes will lead to a sharp loss of oxygen in the atmosphere. This means that in about 1 billion years, our Earth will look like the lifeless place it was about 2.5 billion years ago. That is, before the Great Oxidation event. At that time, the air was filled with methane, carbon dioxide, and other gases, and the planet was inhabited by the simplest bacteria. Some of them learned how to make oxygen from sunlight and carbon dioxide. Throughout billions of years, they made so much oxygen that it became enough for the birth of new, more complex forms of life. And it seems we will return to these prehistoric times. Now, humans can't exist in such conditions, but some complex life forms hiding in the dark depths of the ocean might be able to adapt to the changed atmosphere and become the masters of Earth. These complex life forms are octopuses. There are many species of these animals. Some live in coastal areas, while others dwell in the deep waters of seas and oceans. And some species may be able to survive and create a new civilization. But why octopuses? Because they're some of the most intelligent creatures on Earth, and probably the most intelligent creatures among all the inhabitants of the dark depths. Octopuses can use surrounding objects as tools. For example, they can wear a coconut shell for protection or shelter. In laboratories, they've used various objects to complete mazes. These animals often escape from their water tanks to visit octopuses in nearby tanks. Yes, they have high intelligence, but not in the human sense. Their intelligence is more like a computer. You see, octopuses have neurons not only inside their brains, but also inside their 8 tentacles and large eyes. It's like a big data center, and their limbs sense the environment in exceptional detail, as if they were the brain. Not only their intelligence, but also their physiological properties might help the octopus survive if the apocalypse strikes. Its body has no skeleton. It can squeeze through any hole, slip past any obstacle, and their 8 highly developed limbs allow them to intelligently interact with their surroundings. Crows can bend pieces of wire with their beaks. They can throw stones into the water to raise the water level and get food. But they only have one beak. An octopus with its tentacles has at least 8 times more possibilities. They don't have spines, so they'll most likely build a civilization not on land but underwater, where it's much more convenient to move with such a body. To build a civilization, they'll need to find cheap energy. For example, hydrothermal underwater springs or tides in coastal areas. This will be a difficult task, but it won't be the most challenging thing for creating cities. It's very difficult for them to maintain social connections. By their nature, they are loners, who usually form groups of several individuals. But this is not enough to carry out large-scale construction of underwater urban areas. Parents pass on culture, history, upbringing, and moral guidelines to their children. They spend a lot of time and effort on education. Octopuses don't do this at all. The female octopus passes away shortly after laying eggs. The male octopus has only one mating relationship in its entire life and passes away shortly after the female is fertilized. So, in a sense, octopus cubs are born orphans. It's not surprising that it's difficult for them to build social connections. Over the past 50 to 100 million years, octopuses have not developed a collective feeling, and it's difficult to imagine that it will suddenly appear in the future. Perhaps something will encourage them. Who knows? Some scientists who study octopuses have noticed that over the past 10 years, some octopus species have shown certain social skills. Some live in groups of 10 or more individuals. If humanity doesn't ruin the lives of these animals by fishing and dumping garbage into the ocean, then they have a good chance of succeeding in conquering the planet. But if they fail, then the next candidates might be nematodes, those little white worms. Well, let's hope octopuses win. They seem cuter. They also may achieve a technological breakthrough much faster than we think, because when you have 8 arms, you work much better. Imagine these octopuses leaving Earth and flying to another galaxy, where they meet us humans. Do you think we could become friends? So let's say octopuses become a highly developed civilization that builds cities in the oceans. But they, just like humans, will have to think about colonizing other planets because of the upcoming Ragnarok. The sun keeps heating up and getting bigger, don't forget. Our star is currently in the most stable phase of its life. It has been in this phase for the last 4.5 billion years. But after another 5 billion years or so, the hydrogen in its core will start running out, and then the fun will begin. As hydrogen fusion slows, the core begins to contract. As the core gets smaller, it heats up until it can kick off another round of nuclear reactions, fusing helium into heavier elements such as carbon, nitrogen, and oxygen. Eventually, the sun will turn red and be so gigantic that it will swallow up Mercury, Venus, and possibly Earth. So, it may be Ragnarok not only for our planet, but for the whole solar system. No matter how tough octopuses are, they won't survive such a disaster. Earth is likely to burn down completely. Maybe it'll look like the moon, or it'll completely disappear. What will happen to the sun next? Its energy will run out sooner or later. Then it will shrink to the size of Earth and turn into a white dwarf. When a star goes out, it ejects a huge amount of gas and dust. Only the cooling core remains. All those outer layers will be floating in space, forming a beautiful nebula, and our solar system will become unrecognizable. Well, in some ways, it can sound pretty sad and scary, but hey, look at the bright side. Yeah, pun intended. It's going to happen in 5 to 7 billion years, so relax. Humanity has been living on Earth for about 40,000 years. If we compress the entire history of our planet into one 24-hour day, then the history of people will be equal to 1 second. If we achieve such a development in 40,000 years, what'll happen in 100,000 years, in 1,000,000 years, in 1,000,000,000 years? It's hard to predict. So how about going to the park and enjoying the sun at its best? Yeah, bring some sunscreen.